can you test your mic? Dennis, is Dennis here?
No.
Oh, I think is that Giovanni and Alessandro?
Yes, this is me. Can you hear me? Do you hear me?
I hear you too, thanks.
Okay.
Hello, do you hear me?
Loud and clear.
Okay, thank you.
Thanks.
What about now? Do you hear me?
Yep.
Okay. Great.
Just checking the screen sharing.
Yeah, we can see your screen too.
Okay, great. I'll stop it now.
And your cameras are working too. Looking good.
Okay, I'm gonna check also the screen sharing.
Are you sharing your screen?
Not yet.
Okay.
I'm trying. Mm-mm-mm. Sorry, I don't find the option to share the a PowerPoint window.
Let me take a look.
I mean, I can share the whole screen, yes.
Okay, try that and see if it works.
Okay. Okay.
Yeah, the screen is working,
Okay. What?
and yeah, I see the PowerPoint too.
And if I screen it, if I share it like this, you see the
Oh
speaker
yeah,
mode.
yeah, we can see your notes.
Okay. 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 Then I won't do this. Okay.
Yeah, are you on Chrome?
No, no, I'm on Brave.
Oh, well, I think they use the same engine, but yeah, I see if
Yeah.
has that option.
Okay. Do you think so? Do you think it could be different if I did it through Chrome?
I'm not sure.
Okay.
Maybe try Chromium if that's more up your alley.
Okay. Okay. I will try. So I'll disconnect briefly now.
But yeah, I think it will still work what you just did. It's just that you can't preview your slides, or you can do it on another monitor.
Okay. Yeah. Yeah. Okay. Yeah. We'll just keep it like this.
Okay, cool.
Okay, can you turn it off?
What's going on?
Something got unplugged.
Okay. What the heck happened? Okay.
Oh.
I guess, let's see what happens now. Okay, weird. I just, touched something and that happened. Sorry.
Okay.
Do you need any help?
So did you hear what happened? Did you just hear what happened?
Yeah, there was a high pitched sound.
Yeah.
So
Yeah.
what you do is you slide this up. So the speakers stop working.
Okay.
This is a master volume to control
Okay, I see.
the sound of the speaker.
Okay.
Right now because it's stopped.
So Max unplugged the thing to make
Yeah.
it stop, I think.
Yeah, I
He
unplugged
unplugged here.
this.
Oh, you
And
unplugged
unplugged.
it.
So I'm
Yeah.
hoping it didn't break anything.
Oh, we can test again.
Okay.
Yeah.
Hello? Hello? Do you see it moving there? Hello? Yeah, the voice is on.
Okay.
Okay, great.
Yeah. But okay, what happened was that I was trying to, I touched the.
Oh, okay, yeah, sure. So that happens, that's fine.
Yeah.
So in case you want to control the volume of the speakers, you just
Okay.
turn this.
All right.
This
Got
is
it.
the slider for.
So
the
these
speaker
are
volume.
this and that, right? Okay.
That's
Got
right.
it.
Yeah. So this is the left one and this will be the right one. So
Okay.
left speaker, right speaker.
Okay.
You
Got
usually
it.
just keep them balanced.
Okay.
Uh,
That's all I need to know, right?
okay, yeah.
Otherwise, it's all the settings there. I think you know how to do it. Now,
Yes.
Right? So,
Okay, great. Yeah, I'll be careful next time. And okay, I'm going to go to the washroom real quick, so I don't have to go in the middle.
and now you're muted. So, one thing that you can do is people who are not supposed to be on stage, you can hide them on stage.
Yes.
Right? You can try doing that.
Yeah,
that
yeah.
they don't remain
I was
on
looking
stage.
at how to.
Yeah. So there's
And
the-
it's
yeah.
here.
Yeah.
I saw that I can click here.
Yeah, you can just hide them on stage if they're not going to speak.
Oh, can I hide myself?
If you hide yourself, don't do that because then you
No
will,
sound.
Yeah, you won't be able to share the screen here or something. So for you, just keep yourself on stage, and for other speakers who are maybe giving their talk next, just hide them on stage.
Okay.
So that you don't have to invite them out. All good?
Okay, so we continue to have scheduling difficulties. So what's going to happen is that we're going to not do this, and we're going to start here.
So do we start at?
No, we're just going to move this ahead.
Okay.
So we start with this 25 minutes right here, and we continue through the program. So what I mean, like this slot goes away and everything gets pushed up. So just so that you can follow along, and then if we manage, we'll have something else at the end.
The first speaker is Alexander Parenti, who's already there connected. So you can...
Yes,
yeah.
yes, is already here, and I can unhide him.
I'm going to put the message then in the session.
And who's going to be the chat?
I can do it. Wrong people.
So it's here, so that's fine.
Alexander is here for you. And then we have Jean.
Just listen to around and William.
Alexander, can you hear us? Alexander, can you hear us? Can you confirm that you'll be ready to turn over? In 2 minutes, we're at. Oh, perfect. You're ready for any slides. That's perfect. Thank you.
Oh, I think he is
Yeah.
clicking and rejoining.
Alessandro, for your information, you're still muted, so can't hear you at the moment.
I managed to to enter through Chrome.
Yes,
Do you hear me?
For a few moments, but then it disappeared.
No. Can you have him unmute and keep talking so that we can make sure it works? Can you ask him to keep saying things?
Hi, Alexander. They're testing the remove that yourself. Can you unmute yourself and go continuously so that they can test? Thank you. Oh, we can see your face. So now we can see your face, but now if you could unmute and start talking for them to be able to check whether the sound is working correctly.
Or sing, or read the news, anything, right?
Yes.
But maybe he can
We
hear
want
you.
to hear your voice, Alessandro.
Sorry, I'm not hearing you very well.
Did you want to
Not better. Can you hear me?
Wait a second.
I can't hear very.
Okay, so I think that what's happening is that where is the 1 second.
3 years after the pandemic, still figuring out hybrid.
It doesn't. Is it?
Yeah, especially
It doesn't say anything.
Okay. It's still not showing up. Okay, what's going on?
Okay, so we're experiencing some both technical and scheduling difficulties, but please bear with us.
Let's try a different. Is there a different plug?
I'm thinking of some things to follow up on that. So,
tell us another.
Wait, it didn't complain. No.
so here's a good story. So those big
Why
tables
is
where
this
you
not
put the
working?
values of numbers for computing maximum rent for the
Okay,
house.
so clearly, so maybe I need to pull the cable
There
from
was
here.
a value that was completely too big. It was 10 times too big as the other values in the table. And we realized, is there an error? He said, yes, it's a copy paste. We written that table from another older table. But they told us, rest assured that the
Send
map
it out via
has a
the.
good value.
Can I bodge this
What are
very
good
quickly?
values if they're not
No, I'm just trying to figure out how to work on this.
So I've asked a lawyer if you could sue them to get the inflated value of benefits based on what was on the law and not what the correct value is. So apparently because
Oh, wait, now it's showing up.
the norm is very low in the hierarchy of norms.
Should I tell him?
Executive
Yes.
order,
Okay.
executive order. So the judge would say, oh, they just made a mistake. Even if they're wrong, they're right.
But how would the judge decide which value to apply? Is there a formula that describes it?
No, there is no formula.
Okay, so there's an inflated value, but what's the real value?
So the real
What the
value
judge
is,
use?
yeah, I mean, so it was the 5-4, it was 4-5-9-7, and they forgot the comma. So the real value is just add the comma, it's like 470 cents.
Then you got to make decisions.
Yeah, that's right.
So I think it should work now.
Okay. Alessandro.
Yes, I hear you. I
Yes.
hear even though a bit far, a bit distant. But
Exactly, so we're still missing your slides for information. You need to
Sorry?
share your screen again.
okay, I will share my screen.
Yeah, I feel it's gone.
And then I'll introduce you and then we'll start the. the session. Well, perfect. Perfect.
Okay, do you see my screen?
Yes, we see your screen. Thank you, everyone, and sorry for the slight delays. We'll be starting the session with our first speaker, Alessandro Parenti, who's going to present a follow-up work that's because the Stipula language was already presented on Masters ProLaLa', and now we have the latest news about this department. Thank you, Alessandro. The floor is yours.
Thank you very much. My name is Alessandro Parenti. I'm very glad to be here, even though only remotely. And today I'm going to present you work I did with Professors Cosimo Laneve and Giovanni Sartorra about a method to implement contract amendment using the Stipula language. So let's now start with a brief overview of what the Stipula language is. Stipula is a domain-specific language specifically developed for the creation of legal computable contracts, whose main goal is to provide a language which is intelligible and easy or easier to manage and to use for even non-IT experts such as legal professionals. To achieve this, Stipula's building blocks, main elements, were directly derived from the main concepts and elements of contract law, such as the meeting of the minds, permissions, or obligations. Now, for the purposes of this presentation, I would just like to say that stipulus states, which are indicated with an at in front, um, are used to enforce the concept of the situations of permission or prohibition, thus enacting or precluding certain actions from being taken. While assets, these are the linear resources managed by the contract, such as money or goods. But let's get to the focus of the present work, which is how to implement the amendment of contracts. We know that there may be various reasons to modify to a contract, to intervene on a contract, being it removing material mistakes included by the parties, which weren't in their intentions, to adapt to parties' changed intentions during time, or also to adapt to new circumstances that may occur. This is particularly the case for long-term contract relationships that, because of the long time span of their life cycle, are necessarily exposed to external events that may affect the economy of their business operation. And in this particular context, a particular kind of clause, hardship clause, has appeared. Now, I'm briefly explain what a hardship clause is, just because it's dealt with in the examples I'm going to show. So, a hardship clause is a clause which is used to manage and to the review of the contract in case of unforeseeable circumstances change the the balance of rights and obligations between the parties. And even though the formulation of these clauses can vary a lot depending on legal system, the parties' needs, and so on, we can extrapolate two main elements, two main conditions common, generally present in all of those. The first condition is a change in the initial circumstances surrounding the contract, which is unforeseeable and independent from parties' control to different degrees depending on the contract. And the other condition is that this change produces a substantial damage or an unduly burden on one of the parties. Then this party will have the right, will obtain the right to obtain an adjustment or the termination of the contract. So we saw that there may be several reasons that there may be several reasons to intervene on a contract. However, on the programming leg, from a programming perspective, we noticed that depending on the type of modification, there may be the need for a different type of programming solution. In fact, a modification could imply simply the modification, the update of a variable, which can be considered can be easier to implement, or which is a bit more challenging, can entail the, for example, the addition of a new function within the uh, old code, the removal of a piece of protocol, or even the modification of an existing function to add, for example, a functionality. Now, we try to express all these different situations through higher order stipula, which is an extension of the stipula programming language, which makes use of higher order functions. And we think that this can handle all these different situations through two kinds of operativities that I'm going now to show you in the following examples. So let's get to the example. This is a potential contract, which is a contract for the supply of flour between a supplier and a client. The parties agree that the supplier shall deposit in advance the flour, make this available to the client, and on the moment of purchase, client will be able to get as much flour as they want from the flour available, paying, of course, the corresponding amount of the corresponding price. In Article 4, parties also include a hardship clause in case of unforeseen circumstances that may provide an unduly burden on one of the parties. So let's get to the actual contract code. This is how a stipula contract is written. We have the declaration of the parties, the fields, and the assets. Here you can see the agreement constructor, which is used to implement the agreement between the parties on the main terms of the contract. In this case, the cost of flour. You see the function send used from the farm to from the supplier to deposit the flour. The function buy used from the client to buy the flour, and keep in mind this function for this buy function for later. And in the end, we have the hardship clause, the hardship function. Now, let's say that after some time, but at a certain time, there is an unforeseeable change in the circumstances surrounding the contract that produces a sudden spike in the production costs of flour. This necessarily produces a burden on the side of the supplier, and this is the reason why they ask for an amendment, and they ask to change the way the purchase is carried out, is operated. Parties then agree to amend the contract so that the client will deposit the cost of the product in advance, and the supplier will receive the payment half before delivery and the other half only afterwards. So let's now see how this is implemented. The function hardship is invoked, and we should notice two things in this function. First of all, that this function includes a new kind of input value, which is not required in the other functions. This basically represent the new code that will have to be the new protocol that will have to be added by this party. And also note that this function does not present any body, like in contrast to the other functions. This because the body of this function will be defined in the new protocol introduced. So let's see the new piece of code, which is this shown in this slide. You can see how, as I said, the body is defined at the bottom. A new asset, the wallet asset, is added, which will be needed to implement the escrow, the payment in advance by the client. A new set of states and new functions, of course. And more importantly, we notice how there is no transition to previous state, to the states in the original version of the contract. This means that all functions cannot be called anymore, are no more operational. This means that um, the old code was completely substituted and that there is no conflict or overlay with the previous one, the previous function. This is a first type of amendment that we called additive amendment. Now, let's get to the second type, so with a second example. So let's say that after some time, parties want to return to the old protocol. However, a new law imposes a 20% tax on flower sales. To bear this new taxation, the farm invokes the hardship clause both to increase flower price and to implement the tax payment. Now, let's get to the actual new piece of code. The hardship clause is the hardship function is invoked. As before, you can see that the body of the function is represented at the bottom. We notice how a new party is added, the government party, which will be needed to implement the tax payment to the state. And we see that we went back to previous states. So the states present the state present in the original version of the contract. This means that the functions present in the original version of the contract become operational again. And in particular, if you remember, in the original version of the contract, we already had a buy function. This means that this new function introduced now is overriding the older function. Now I will get to the explanation of this, the functioning of this overriding in a moment, in the next slide. But this type of modification is instead, this type of amendment is what we called an overriding amendment. So in a summary, we saw how higher order stipula can both handle situations where we have to add new functions that are not in conflict with previous ones, and also situations where we have to modify existing functions. Now, this last one can be a bit more challenging, a bit trickier, because as we saw in the second example, this entails the introduction of functions that are in conflict with previous ones, with older ones. Now, this conflict, which is technically called a dispatch, in higher order stipula, is resolved through priorities and constraints. Now, constraints are simply the conditions that have to be satisfied for a function to be called, and this is indicated in brackets next to the function name, as you can see in the red square. And for example, this constraint means that the client can only buy an amount of flour which is available in the contract, which is lower or equal to the flour available. And so what does priority and constraint means? Let's get to this. And here you can see um, the the by function present in the old and the new code, and you see how the header of this function is exactly the same. So same state, same name, and same constraint. In this case, the conflict between these two functions is resolved through priorities. Through priority, so giving the priority to the newest code added. So in this case, the new by function will be called, and the old one won't be operational anymore. But we could have thought of a situation where where we wanted to introduce the possibility for the client to also ask to buy more flour than the one available. In that case, we would have we would have defined a constraint that said that that value W was higher than that formula there, saying meaning that he could also ask for more flour than the one available. With this setting, we would have two different functions, two same functions that would be called differently depending on the input value given by the client at the moment of calling. And in this way, this is what priority and constraints in the managing of the dispatch mean. And these are the functionalities of the stipula higher order. This is the formal definition of the higher order function. I don't know if I have, I don't think I have the time here to explain this. You can find the explanations on the paper. And now just briefly go through um, some work we've been currently doing to further improve higher order stipula. One of which is the possibility to implement the possibility for the parties to um, express their consent on the modification introduced in accordance to the general principle of mutual consent to contract modifications. And in this context, we would also like to deal with all the exceptions that the legislator may as have the legislators have traditionally given to this general principle, such as the sometimes the legislator gives the right to one of the parties of the contract to unilaterally modify some parts of the contract. And at the same time, we would like to also deal with the situations where, in, for example, multi-party contracts, in order to modify certain parts, we we could a certain majority, a qualified majority of consent between the parties may be required. And another further work we have been working on is the possibility to um, to have constraints to the amendments introduced by the parties. We could think to configuration of a system where parties may want to preclude, for example, the parties themselves to be modified by any amendment, or they may want to preclude the update of certain fields, or the reachability of some states in order to preclude some functionalities. So this was all for me. You can find the Cipla prototype to this link, and I'm thank you very much for the attention, and I'm open to any questions.
Thank you, Alessandro. We're going to take some questions. We have a few minutes. Are there any in the audience to start? If you're ready, please type your question in the chat.
I'm not hearing very well.
Alessandro, I was saying that we're moving to questions.
Okay, perfect.
From the audience, we have any from the, so
I have one question for you, Alessandro.
Yes.
What was your methodology for gathering the example of contracts that you use to determine which features to add to the language? And also, it's interesting that you found the higher order thing to be useful. It also resonates with my talk this morning, but interesting. So, yeah, the main question is about the example collection methodology.
Thank you for this question. We simply look to examples, to situations that could be fitting for for modification situation, for amendment to contract. So we thought that and also situation that could clearly be found in practice. And we think that in this case, um, hardship clauses and hardship situations are very common, especially given our times where circumstances have changed in our societies and have given a lot of problems that like this. We can simply think to the pandemic situations or wars. These are situations very commonly found in practice, and that's why we thought to this example in particular.
Okay, okay, thank you for the answer. So, but you don't have a specific set of real world contracts that you collected from somewhere. It's just
No, we didn't collect it from any set, but we would like also to give more let's say reality to our example. So we will look forward to do that.
okay. Well, thank you very much, Alessandro. I think we
Thank
can
you.
move on to the next speaker,
Thank
who's
you.
Jean-André Silver, if I'm not mistaken. Yes. So, Georges, now you should be able to share your slides with us. And you can, wait, yes, we can see you now. Can you try and talk?
Yes, thank you.
Perfect, it's working.
Okay, great.
The floor is yours. About automatic consolidation of French law.
Okay, so thank you and good afternoon. So today we talk about automatic consolidation of the French law and some automatic system to do that on the fly every day. And I'm very happy to have a dynamic community of people interested in computer science and law, because it's a subject that I work on for almost 20 years now. And in fact, I'm very happy to see a lot of people interested in that. So the main research question I tried to answer is it possible to build an automatic consolidation system of the French and the European law with 100% reliability and to maintain this reliability over time? And in fact, this is a question that has been asked by the French official journal producer, and because right now they have some manual system. But let's first try to understand what exactly is consolidation, because all legal systems don't use consolidation as their main way of publishing the law. But let's have some time to discuss about that. So in France, the law enters in force only if it has been published in the official journal. So anything that hasn't been published in the official journal doesn't come into force. And in fact, a published law enters in force the day after its publication, or maybe later, because it can be delayed in terms of entering in force. And the successive modification of the law are also published in the official journal, but under the form of patches. And it resembles something like code patches, but it's patches of the law. And in fact, the consolidation process applies those patches and creates some for a specific version of the law at a specific date. It creates some version of the law, and those versions of the law are not published in a complete form in the official journal. So it implies that they have no legal values. And in fact, this process is currently essentially manual. So every day there are people working, taking official journal and trying to understand what has changed and applying that manually to some version of the law that is published online, for instance. The problem is that lawyers and lawmakers, they only use those consolidated versions to work. For instance, in fact, the new laws are created from consolidated versions, even if, in fact, those versions doesn't have any real legal value. So this process must be as reliable as possible. Let's see an example. Here is an article of some French law published in an official journal. You can see that, in fact, it looks like a patch. So means we have sentences like at the beginning of the first paragraph of the law, blah, 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 we add some one, and then in the two here, you can see that we in fact replace some words, etc., etc. So really, it's like a patch. So this is what is published in the official journal, and this is in fact the target of the modification. This is the article being modified by the law I displayed just before. So this is one article of the Commerce Code, and in fact the translation is made by me, so it's not completely it's not an official translation, but I think the French is difficult to understand for everybody. So so let's see now the process. How is it working? In fact, the law here is published in the official journal at a given day, and some people start to consolidate this law and create, in fact, if you look at the text here, in fact, it creates two new versions. The first version is a version that is created from this text when this text enters in force. It means that a new version will be created October 26. And you can see here that a second version is created on January 1st. So it means that if you look at the process here, someone just has to take the text published in the official journal, has to apply the changes on the article 7234 of the commercial code, then creates two new versions. So this is the ideal scenario. So someone takes the text and, in fact, creates two new versions. And this is done by some specific software where you can replace text. But this is very basic operations. So this is a result of the changes. You can see in blue everything that has changed in the first version occurred, induced by the modifying text. Sorry. And this is a second version that will be enforced, that has entered in force in January 1st, 2023. So why do we try to automatically consolidate? The problem is that the constraint time to manually consolidate the text, they cannot always be respected. For instance, there is no one working on Saturday and Sundays, even if the official journal is published on Saturday and Sundays. You also have huge texts implying that there are a lot of changes to apply, and sometimes you don't have time to do that in one day. So there are some misleading, even wrong information published on Légifrance, meaning that if you look at the law on Légifrance, maybe you are looking at a bad version of the law, and even if you think that this version is enforced, it is not. Also, the manual consolidation is only a syntactic process. You cannot trace back, in fact, the exact actions that generate, in fact, some version of the law. And also, there can be consolidation errors. And the redaction of the new text, there are also manual. So there are also errors in the redaction of the law. In fact, we should have some way of encoding, in fact, the change under the form of a program, for instance, to automatically apply that. This is the goal, in fact, of automatic consolidation. So what we try to achieve here is, so first, let's see of an example. Here is an example of an arrêté. It is some kind of law in France that has been published in the yesterday's official journal. In fact, if you look at the Légifrance website today, in fact, this arrêté changed an arrêté of January 9. If you look at that online, the law that is published on Légifrance is false because it hasn't been changed by anyone, because no one is working on Saturday and Sunday. So some figures about how many, the number of texts that are changed by year, for instance. This is a mean of the number of texts published in official journal, and 3,000 of those texts change another text, resulting in 38,000 articles change per year. And in fact, it's 127 articles change per day. per official journal published. And this is definitely a huge work to do manually. So what we try to achieve is to do that automatically with a system called Logistics. This is a research project started 2 years ago at MinParis. And the question is to build, in fact, and maintain automatically a graph representing the full structure of the French and the European law. And in fact, the idea is not to understand the law, but it's only to understand the logistic structure of the law. It means that how the law is organized and how the law changed, by which text each article is changed, and so on. So the idea is really to capture the evolution of the relation between documents and set over time. And automatic consolidation is one of the sub-programs of the graph constructions we try to achieve with the logistics project. So here is a very partial example of a graph. So this is some very simple example. For instance, the example I showed before, it's this law 2022-1348 is in fact changing some version of the article of the Commerce Code with some relations like creation, prepending, replacing, and so on. This is exactly what we want to capture in this graph. In fact, we don't want only to capture, in fact, that in a graph, but we want to generate automatically the code that creates this graph. The data we are working on is, in fact, the open data provided by Legifrance. It's approximately 1 million texts with 2.3 million articles. And in fact, there are, in the manually consolidated database that we also use, something like 1.6 million article versions. And the data are imported daily and analyzed in a huge version database in the logistics systems. So the different phases of the system are the following. First, we need to recognize the reference of the modified text. So for instance, in the example before, we need to recognize what is in blue, the article let 7234 of the commercial code, and we need to retrieve that in the system, in the logistics system, meaning that we need to transform, in fact, the text, the natural text, into some ID to have, in fact, the target of the modification. And then, more tricky, we need to determine the version of the reference text, meaning that we need to know exactly what is what are the different versions of the text that are changed. In the example before, we need to recognize 2 versions. So, in fact, after this step, the creation of the modification program can change. So we start, in fact, from what I showed here. We start from this article, and we try to transform that into a program. So we can start here building the program, and the program will be, in fact, we will start first by getting the 2 versions of the source and the target of the modification. At some specific dates, and those dates are inferred by analyzing, in fact, the source text. And then we can create 2 new versions of the text, a version V1 and V2. Both are versions of the T, which is a target. But you can notice that the version 2 is created after the version 1, because we need first to have the version 2, and then we can transform, in fact, the version 1 into the version 2. Everything we do here, in fact, is done in the lazy mode, meaning that we don't actually change when you do new version. We don't actually change nothing. We just, in fact, try to schedule the change with lazy functions. Almost all the methods I show here are, in fact, returning a function, which is, in fact, a closure that we can apply next to the text. So here is a full program that is generated, for instance. So after generating the version V1, we can, in fact, schedule the change, and all the change that are described here, in fact, they just capture what is written, in fact, in French language. And transforming, in fact, you can notice the par methods, for instance, are lazy methods because they are not applied here. It just means get, in fact, the paragraph that starts with a 1. Here gets a paragraph that starts with a 3, and so on. And then, in fact, once we schedule the change for the V1, we can schedule the change for the V2. And you can notice that the V2 is obtained after the V1 and so on. Then, when we have that, we can, in fact, we have a program that when run can modify the text from a specific version by creating 2 new versions automatically. And this is completely generated, it is generated completely automatically by the logistics system. So the full system, in fact, so for each published official journal, generate all the programs induced by the modifying texts, and then apply the change after all the programs have been generated. For each, apply the change to generate all the new versions of the articles we want to obtain. In fact, the consolidation system has been built completely gradually because, in fact, we have the manual consolidation, the past manually obtained consolidated versions. So we can compare, starting from the first version of each text, what our system returns compared to the manual operations. And if they differ, we can say that either the manual consolidation is wrong or the automatic rules are false. In fact, the full process can be restarted at any time to check for regression issues when we change a rule. And we did that for all texts in the Legi database that I presented before. So the current status of the system is that we have now fully automatic creation of programs that modify text and create versions using the method I just showed. And in fact, we introduced a new functional API to express lazy modification programs. This is the example I just presented, because the example I presented is a real code that can be executed. We also have an engine to apply those transformation programs with the validation methods I just presented. Right now, it's implemented in Python with some C code for speed to speed up, in fact, the parsing of all the huge XML text of Legifrance. And we also have a framework to compare manually and automatically the consolidated text to have something that is robust. The next step of that is to continue to refine rules, because right now we are now at 100% reliability. We are at 93%, which is already a very good score. And we want to introduce some hybrid system where we use rules and machine learning, in fact, with already consolidated data as a training set, so that we can, in fact, detect future forms of changes, detect errors that occur at the same time in manual and automatic consolidation. That is a possibility. And we also need to reinforce the formal system of rules. And then the next step will be to apply those techniques to European data. And in fact, we need only to adapt the identifier and the change detection, because the API will stay the same. So thank you for your attention, and I'm waiting for your questions.
Thank you very much for this presentation of this very impressive work. I will take questions from the audience. I'm sure the members of the audience want to know more about the technical details or other aspects of the project. Yes, Lawrence? Yeah, thank you for reminding me of my duties.
Is it working?
I think so.
Hello, thank you for a really interesting talk. It's like a great system, and I'm sure you're aware of the code and source code. I wonder if
sorry, I don't hear nothing.
Can you?
Hello?
No, I don't hear. I don't hear well.
Ask your questions and I'll repeat it, because I have the impression that the mic for the remote speaker is faster.
Do you mind?
No.
Yeah, so you're probably aware, first of all, thank you for the paper, a really interesting system. You're probably aware that in the EU at least, and I don't know about France, but probably, new legislation is being produced and drafted using Acoma and Toso, the XML format. And I just wondered what impact that would have, or what positive impact that might have on the system because of its structured nature. Particularly, you made reference to using regex, for example, to identify elements of the document, and of course, a structured format like AKN would provide that. Acoma and Toso would provide that. So I just wondered if that would play any role in the future development of logistics. Thank you.
Yes, indeed, because in fact, something I did not mention is that the text we can produce with a program, in fact, captures more information, meaning that for almost for every word or group of words, you know exactly where those words come. For instance, you know that some group of words comes from the change from another text. And that you can capture that with XML because if it's hierarchical nature, and formats like Acoma and Toso can be very, very useful to do that, to express very rich contents with links inside the text. So definitely this is something I'm looking at.
Thank you very much. Do we have other questions in the room? I think there is no further questions on air needs. I have a question for that. I think I have a question for you.
When you speak of the rules that you have to refine to basically get the changes right, are these all regex, regular expressions, or do you have something more fancy for text transformation and manipulation?
This is definitely more fancy because, in fact, the regular expressions are there to. In fact, at the end, I need a regular expression because I need to have the parts of the transformation. Because if you want to transform that into code, you need to have a very precise way of producing lexems to have the different parts you can transform into code. But to achieve that, there are in fact some streaming grammars with some very simple backtracking to be able to try something, and if it's not that. In fact, there are some refinements, and in fact, we have grammars that are composed to in fact detect things and then go back when it's not the right one. And it's definitely more fancy than regular expressions by themselves. It's regular expressions plus ad hoc grammars.
Okay. Is the code open source? Can we go somewhere and have a look at these grammars? Because
very soon.
Okay.
Very soon. Right now, it's not production ready, so I think I will do more cleanup.
Okay, I see.
Yeah, but it will be definitely open source, and in fact, the results also will be available on the web. I mean the transform text with the enrichments I just mentioned.
Okay.
Okay.
If we don't have any more questions, we can thank the speaker again.
Thank you.
And the short talk by Thomas Hildebrandt about the ECR graphs and their applications to the image flow.
Okay. We need to toggle technology works.
What do we need? I think we need to be on the script. No. Okay. We need to. First, we need to put this in. Oh yes, we're getting a black screen here. That explains it. Okay, and then we need to project.
Whoa. Okay, perfect.
Okay.
To share screen.
Nope, that. Stop. Okay. Thank you for the session. So I only have 10 minutes, so let me just start. I'm from Denmark, and I'm going to talk about this modeling language we have developed over the last 15 years for making executable models of the law. And I have a research section of 30 people, combining people who look at ethnographic methods for understanding work practices and then formal methods together. And I've also been doing quite a lot of number of projects joining computer science and law. But the main motivation of this is, of course, that we have a lot of digital services that embeds law, and we have seen several examples at this workshop already. And to have to meet these sustainability goals, we also need to have a fair practice when we exercise law. So we really need to know that these systems embed law in the correct way. And the problem is, of course, that if you use code or use fancy process diagrams or decision tables, there's still a translation gap that makes it pretty difficult to maintain and understand these models of the law that are embedded. And in Denmark, we actually have letters being sent out to a citizen saying, okay, now your pension has changed, or now you have got this rejection. It's all automatically calculated based on models of the law in some computer system. And you have no idea as a citizen to kind of challenge this decision. I mean, you can do it, but you only have a few weeks, and if you don't complain, well, your pension has changed. And we have a lot of directives also coming out from the European Union, so the problem will just increase even more and more in important. So the Danish government has for many years kind of bragged and say, well, we have this initiative for digitization of the law, but in fact, what they're really doing is to try to simplify law so it's easier to implement with traditional methods. And that's never going to work because people, I mean, the politicians keep up making laws, they're not going to make simpler laws. I noticed there's also a European office actually looking at this digital law, and then there was an interesting report coming out from New Zealand that also looked at the problems about the digitization of scope. But what did we do? Well, we developed a system jointly with lawyers, municipalities, computer scientists, and critical computer scientists, allowing people to take the text from the law in a system, highlight what is the role, what is an activity, what is a rule, and then you have these dual views of the same model, where you have a graphical graph of the rule. And then you can go on and, oops, yeah. You can put this into the tool, you can get the models, and then you have a process engine so you can simulate these models, and you can expose them as dynamic guidelines that you can use as an end user. You can also embed them in a case management system, so you get checklists telling you what to do and what are the deadlines. And finally, you can actually do process mining on what people can actually do, and then you get a picture of what are the rules people actually follow. And then we can compare this to your original regulation. We haven't done so much formal verification yet, but since there's a formal mod behind, and if you stay within the core subset, it's final state, that's actually imported into the formula and use the model checkers, or you can develop your own model checkers. So before we will stay in the final state. If you do not stay in the final state and move into the true complete fragment, then you can still do some static analysis. And we have done that in research papers, but the company has not implemented that. There's not been demand for that. So it came from a formal model called event structures, developed many years ago in the 80s. We made this model that generalizes event structures, so you can do the activities or the events several times. And then we made industrial tools. And it's actually embedded now in a big workflow system sold by ADC Corporation in many countries around the world. So
Formally, it's a graph. In the core model, there are 5 different relations, and then we have a lot of extensions. And you can locally decide whether an activity is enabled or not. I will show an example. Here is the one from the Danish Conservation Act for Social Services. It's only 1 paragraph and only 2 sections in the paragraph. But this is, you can click the link and you can see it online. You have actions, you have roles, you have rules. And there's also, we also made some suggestions. We can use NLP to try to suggest where we have actions, roles, and rules. It's not 100% NLP, but it can help you start more. Then the graph looks like this, and you can click the link and you get into the simulation tool. And here we can see I have started the simulation. There's only one enabled activity. Receive a notification of child because you have these condition constraints to the other activities, making them not enabled yet. And if you then execute the receive notification, some more activities became enabled. You also have an obligation to acknowledge receipt with a deadline. Because you can put deadlines on these obligations that are dynamically created. And then if we go on, you can actually set this receipt. You can execute this activity, which is a data activity. So you actually provide some data when you execute it. Right now, just this and no. And that will then be used as a guard and constraint to either dynamically include or exclude this. You have this dynamic exclusion and inclusion of activities. There's an example of this library obligation, where we dynamically create a notification of returnables or not returned. So you can model these above. So that was over lunch. So we have extensions. You have seen extensions to the core model with time, which is essentially extending the delays and deadlines. We have extensions with data, imputation, and the conditional relations. And also sub-processes, so you can do hierarchical modeling and also dynamic spawning new sub-rules you have to and there's a lot of papers. It's 15 years of work that one can look into. Ongoing work, we look at modularity and more modularity, combining different graphs and having links, because you can see in the regulation that you have some paragraphs referring to other paragraphs. Of course, we would like to model that in different graphs and then link them to each other. We have done it in theory, but the company has not yet implemented it. So that's a paper I created some years ago. We work a lot on this process mining, which is really looking at log files from existing cases. And then we have now a tool that can mine what are the rules people follow. It's actually pretty good. It won the best process mining effort award a couple of years ago. So, studies where we had a graphic view where we listed the case for people remembering it, but the actual decision, it does not make sense, because it is even stated in the law that you're not allowed to put rule over discretionary discretion, so you have to have a caseworker there. Okay, so this is the overview again in the pipeline of tools. And yeah, of course, some of it is open source. We developed an open source case manager client. These tools are free for academic use, so you can make an account and you can play with it. Yeah.
Thank you very much. We can thank the speaker. Are there any questions in the room or on Airmeet? In the room. Well, I have a question, but I prefer to get yours first. Okay. So Thank you, Thomas. Clearly, this is a long line of research, and the DSL you have developed is very impressive. Are you aware of the limitations it could have in terms of what sort of flow you can formalize with it, and what sort of flow you see that it's not very suitable for formalizing?
It has been gradually extended when we found these limitations. So right now we can do quite a lot. For instance, we added this time following an ISO standard for time. So now we can also express rules including time. So right now we are not meeting the limitations.
Okay.
But I'm sure we will at some point. And I think one big limitation right now is to have implemented this modularity, because otherwise it will not scale.
Yes.
Because even though the graphs are pretty one-to-one, laws are complex, so you don't want the entire law in one graph. Yeah. And of course, I noticed one limitation in your talk, which is I think they are calculating with floating points, so I should go back and. Yeah.
Okay, we have another question in the room.
So if you were wanting to add formal analysis, what would be the first analysis that you would be adding to your tool?
So we have done reachability. It's NP complete, but it can be done, and we have there's some algorithms implemented actually. But we would like to have an implementation of whether one graph is a refinement of another graph. And we have the theory for that. And then also using it as a model checking tool. So you say, okay, is this graph a property satisfied for that one? What they have implemented right now is that you can specify graphs and then you can run them on a trace. And then it can tell you quickly, is it true or not? But these are the kind of analysis. Then we have also formalized what does it mean for a change to a graph to preserve the original language. So you're only restricting what could be done. So these kind of implementations would be nice to have.
Thank you very much. We're running low on time since we're going to switch to the next speaker, but we can thank Thomas once again. And the next speaker will be remote. It's William O'Hanley, which you can promote as a speaker. O'Hanley, H-A-N. Yeah, okay. Yeah, that's him. Perfect. You can remove Jean. Okay. William, can you hear us? Yeah, can you try and speak again, William? No. Can you try and speak and say something? No, we can't hear you, unfortunately. This is better now. There's a lot of noise, and the sound quality is quite low, and we got a lot of feedback also. No, we can't hear you now. Perhaps if you remove your headsets, it would be better. Try.
I expect this would be worse, but is it okay?
Yeah, it's way better now.
Okay. All right. Well, I'll do this then. Sorry.
Thank you very much. So go ahead. You have your 10 minutes to talk to us about Wisescript.
Yeah. Thank you. Yeah. So I'm Will. I'm a computable contracts developer at Codex at Stanford. I've been working on some kind of off the side of my desk on some visual programming focused tooling for Wisescript, which is, as its creator says, a computer language for representing and manipulating propositions. So this is a language for legal expert systems based on propositional logic. There's a sample on the right there. You've got code organized into rules, which contain Boolean expressions. It's part of like a broader set of expert system tools, which is called DataLex. Pretty much constitutes the entire existing tooling around YScript. It looks like this. Is my screen dimmed?
No, no, it's fine for us. We can see
Okay.
it.
It looks dim for me, but that's good. So it looks like this. It has this kind of chat style interface, similar kind of vibe to like doc assemble, lots of other stuff in the space. It also has a couple of other interesting features that I don't see in many of those cousins, and that kind of started me on this path. So it asks you questions. It's got a pretty simple algorithm for deciding what question to ask. It's basically just the order facts are referenced in the program. You give a new answer, you get some new conclusions. You can ask for an explanation of any conclusion, and it'll give you, that's a pretty simple one, but it'll give you a trace if it's longer. You can do this hypothetical reasoning, which I think is really nice. You can just see what the conclusions would be if you said something. And you've got this, there's another thing you can do, which I don't know why the button isn't showing up now, but you can ask why you're being asked a certain question, like what it's going to help determine. I think this is really cool. I think a lot of us are probably familiar with this kind of interface. This is, I think, one of my favorites in this style, mainly because of those like what if, why, how kind of features. It shows lots of context. There's also a lot of like natural language stuff it does that's cool. DataLex, I don't have time to talk about all of it, but it's worth giving their website a once over. I think they have a lot of good ideas. But the why and what if are kind of how I got started, because I like them a lot, and I think I want more of what they do. This idea of like looking back or looking ahead in the evaluation of a program like this is really nice, and I'd like to be able to go more than one step. Also, these explanations, you see things like what DataLex does in a lot of tools, which is you ask for an explanation of something. YScript doesn't call it that, but a lot of people do, and you get a derivation tree basically, or an evaluation trace. And I think that's nice, and it's useful for some things. And it's not exactly what I think of as an explanation, and I kind of wanted to explore a little bit what I do think of as an explanation. To me, I think explanation is about building understanding, and particularly the thing I'm interested in is explaining a set of rules, not just a particular application of those rules, which is a different set of things to be explained. Right? You want to know how the rules interact, which rules are important, which ones you think about first, whether some rules are mutually exclusive or only relevant in the context of some other rules. The reason I sort of have been putting work in on this is at Codex we're working on a lot of insurance stuff, and the idea of explaining an insurance policy, it's quite hard to just explain particular claims over and over and come to an understanding of the policy. I could see like 20 different claims and their determinations, and I might sort of start to build a bit of understanding, but I really want that like big picture view of a policy, and I don't think you get it from the kind of chat style interface. It's really, this like looking one step ahead or one step backward is nice, but really what I want is to understand all of the avenues of possibility and track how and why those avenues are opening and closing as I reveal new facts. And also this issue of asking the right questions. I mentioned DataLex has quite a simple algorithm for it. I I think that's fair enough. I think it's actually a really hard problem. And there's, a lot of people trying to do work on relevance. I think it's maybe too hard, at least for me to solve. And I'd rather avoid the problem and just like not ask questions as much as possible. And I'll show you what I mean here. This is what I've been working on. It's a VS Code extension, kind of your classic boxes and wires type of thing. First important point about it is it's all text first. The graph here is derived entirely from the YScript source code. It's not something you'd like build separately, aside from a bit of positioning metadata, but that's okay. I like text a lot, more than I really have time to get into here, but Great and Horror is a great blog post, always bet on text, if anyone's read it. I just really wanted to avoid the graph having its own kind of opaque format. The graph just is the code, but a different view. So we can see, like, let's say this one, whatever. As we edit the code, the graph changes. And you can link back. This is all tree sitter. I wrote a tree sitter parser for YScript, which generates a concrete syntax tree. So we can always connect something in the graph back to its source text, which is really useful in a kind of a larger program. Tree sitter is also quite error tolerant, so it doesn't matter if it isn't valid. Well, it's hard to write something that isn't valid. There you go. YScript has quite a loose grammar, which is nice. But it's good that it's tolerant, because a lot of the time when you're in the middle of typing things, they don't parse, and we want to still be able to do something with a partially valid program. Rule boxes are just very simple HTML. Particularly, you'll notice they don't have any editing features. I used to have that. I took it out. I think it's better to just link back to the editor and do whatever you want there. The editor is always going to be more fit for purpose. There's also, this is kind of the main thing I wanted to do, which is just set the value of kind of arbitrary facts and see what the implications are. You can say pick a goal rule, which is how you tell YScript this is the rule I want to start with, and like determine a value for the fact it depends on, and it'll kind of take you through in the same way as YScript does, pointing to facts in a certain order. I should animate that hand, but whatever. And it's nice. I do really like that. I think it's nice to have a little like tour of the rules, but it's also really nice to not have to follow it. You can, if I just want to like cut this off completely, it's like, I know it's not this. I don't want to answer all those questions. Just don't even ask me about it. You can do that. It'll make all the inferences for you. It's got kind of a nice like spreadsheety feel to me a little bit. You can kind of test these hypotheticals for no real reason and just see what happens. It's very like low ceremony. And I think it's quite helpful for sort of building an understanding, not just of how a single result was achieved, but like how the rules all together work.
So, William, I would suggest to move to the conclusion, since we're kind of up with the 10 minutes.
Sorry, am I out of time?
Yeah.
Okay, that's fine. I'm done anyway. I was just going to noodle a bit, but if we're out of time.
So do you have some final conclusion words before we move to questions, or?
I guess my main kind of idea, and the thing I've been thinking about while doing this is, I think tooling is really important, and I think there are a lot of like really cool languages that don't go anywhere because they never get the tooling they deserve. I wanted to like focus on that question. I think YScript is actually a really cool language and really useful for this niche. And I like to see it have good tooling.
Okay, well, we can thank William for his presentation. Do we have any questions in the chat or in the room? Yes, I'm giving you the mic.
Yeah, at some point you mentioned that you wanted to use your language and explore a bit more like the future scenario that you could come up with, etc. But I'm wondering, like, this is the very classical problem in any formal analysis tool, like presentation of the results to the users. If you have many time steps and a very complicated mathematical object at the end, you will have probably a hard time finding a good representation for that. And I was wondering whether you had already some ideas or some clues about this.
Yeah, I think my idea is to just try not to have complicated mathematical objects. It's why I like propositional logic for this. It's why I like YScript. And I think it's also, at least here, I'm actually using Z3 on the back end. So I could, in theory, have like some quite complicated mathematics going on under the covers, especially if I had a more sophisticated logic. You know, in theory, I could do this with predicate logic. And I do have some like similar tooling underway with that. But I just don't show it, right? I don't explain things in those terms. Like, I think it's less important that people understand the mathematics as they than that they kind of develop an intuition for the dynamics of the system. So I think my solution to the problem is to just not address it. It is really hard, and that's why I don't want to do it.
Okay, well, thanks, William. We're already running low on time, and I would like to give the next speaker the occasion to catch up on the talk that has been scheduled over the day. So we're now thanking again William for his presentation. Questions. And welcoming Emma to talk about consequences of privacy policies with answer set programming, a common recurrent theme in ProLaLa'. Emma, you have the floor. We can thank Emma and applaud her for her resilience throughout this process, which will hopefully resume to a happy conclusion.
Can people hear me now?
Yes.
People online can hear?
Online, yeah.
Okay.
Okay, that works. Online works.
We'll unpop the color. Yeah.
Congrats.
Yes. Woo! Okay. So I don't need to go over too much for the people online who've not been able to chime in. All that they potentially missed was the saying in Latin that I, again, am not going to try to say in Latin about how ignorance of the law is not an excuse from the liability that you incur by breaking the law. So the important part about this is that there are many things in our lives where we don't necessarily recognize them as laws, but they govern our behavior nonetheless. And so an example of this is, of rules that are out there are things like policies that we agree to when we engage in, various activities with entities. And so, of course, policies that people are maybe, very familiar with here as computer scientists would be, for example, privacy policies. And so this is a quick screenshot from Meta, but there are many of these things out there. I'm sure everyone here does the same thing I do, which is scroll through terms of service and all these things that pop up just so I can get the thing that I need to get done. Although I do read through them from time to time, and you can find little tidbits in there on how to find yourself to be exempt from them. I do that when, for fun. In any case, the question we have here when we're engaging with these policies is how do people actually, understand them? And so one thing to start thinking about is what the possible outcomes are and how are they determined? And so initially they're determined by things like code, so what the software actually affords, so what is actually possible through the execution of software. And then what the user behavior is, so how do users interact with code? And so this idea of what's possible is something that we engage with every day when we're playing around with systems. But we're all here at ProLaLa' right now. We've seen a lot of discussion about the idea of what is permissible instead. And so the way that we reason about what's permissible is we need to start encoding things like what the legal statutes are and what the firm's own policies are encoding. Because these two things interact with each other in certain ways, and sometimes the firm's own policies are going to be more expansive than the law or are going to have things that are not currently well defined within the law. So knowing this, we've seen a lot of discussion about these sorts of things today. There is an idea that has sort of been alluded to throughout the day, and a big problem here, which is that these kinds of things, legal reasoning, are very difficult for people to understand. Not even legal reasoning, right? Because you hire lawyers and no one who's working on this team is a lawyer. But just in general, user policy, privacy policies that we give everyday people to sign, we know to be very difficult for people to understand, for end users to understand. Even people who are experts have difficulty understanding these things on first pass. And so there's been prior work that has established that. That's what's cited here. And so this is something to keep in mind when we think about various systems that are actually encoding behavior and outcomes. So a possible solution here, that should be unsurprising from the title of the work, is to use what's called narrative. And so, it's pretty straightforward. We can see here from this image that when we say narrative, what we're really talking about are stories. And so we can think about narrative as giving us a kind of explanation for how things work. So rather than giving people a rule set that they have to interpret and forward simulate, we're instead going to give them a set of stories that are relevant to them. And so this dovetails nicely with the last talk about what it means to actually comprehend a system. So I'm going to pivot briefly from the previous discussion about wow, I just gave away the game, about privacy policies on websites like Meta. And instead, we're going to actually talk about HIPAA for a moment. So this is a law that is particular to the US, the Health Insurance Portability and Accountability Act. And so it's something that describes how your data can be transmitted. And so you may be wondering, okay, this is an interesting setup for privacy policies. Why are we pivoting to HIPAA at this point? So the first reason is that there's a long history of people studying HIPAA. And so this is great. It's well established in the field. It's well understood. We're not turning our attention to something that's perhaps underspecified. It also has some prior formalization. So because there are very serious consequences to errors in reasoning about the application of this law, it's very important for people who study it to have spent time actually working with experts. And because of that, because of these prior formalizations, it means that there are actually resources for non-experts. So it's a nice entry point if you don't actually have a background in law to start to understand what some of the legal obligations are regarding this particular law. And so if we can build a system that can work with HIPAA, the idea is that we could eventually use some of those techniques and apply them to other contexts. So what narrative gives us is a possible solution to the explanation problem. And so the idea here is that a narrative ends up having a sequence of events that are in some way related. And so you could have a person who asks about a particular scenario or particular outcome of interest, and the narrative generator will give us a sequence of events that could cause that particular outcome. And so the underlying mechanism that and technology that we're using to enable the system is this idea of narrative generation and policy formalization. And we're using ASP in order to produce these artifacts. So this is a summary of the general approach. And the key idea here is to use these narratives that actually describe entities taking actions. So these are two really important points here because we now have a system where we're talking about components that are slightly different from perhaps the way we might traditionally think about like propositional reasoning. So again, to be very clear about what we mean by narrative, is that a narrative is a sequence of events, right? And so it has to be something that is temporally related, and those events should have some sort of causal relationship with each other. So as a disclaimer, and they should be related in a way that an end user would understand to be a story. So as a slight disclaimer, if you have questions about this is a very well understood subfield of AI. Chris has like amazing expertise in this. It is the person to ask questions about. I am only just learning about this right now. My background includes things like statistical causal reasoning, which is a bit different, and some statistical explanation. Happy to chat with people about how these are connected to each other. But in terms of the purely symbolic reasoning, if you have questions about this, please put them in the chat because I can guess, but Chris is the expert on this. So in any case, this is very cool. This kind of work describes how actors behave in an environment and how they might change the environment and how information is propagated. And so what we've done, in particular Shemaya really has done, is to encode the entities that are described in HIPAA according to a hierarchy. And one of the nuances of this work is that you can't necessarily have a strict, what's the word I'm looking for, like disjoint union of roles, for example. And so there are cases where either contextually or like mostly contextually, there are actors that can take on various roles depending upon the situation, what the situation entails. And so this is something where being able to reason in a compositional way is really critically important for this work. And so these entities end up being encoded in an ASP system. And then there are actions that actors can take. And this is an example of the encoding of the policy, the HIPAA policy in ASP. And so this work actually uses narrative infrastructure that Shemaya and Chris had worked on previously. This is an AAA aid paper from 2020. And it describes a reusable system for giving information about narratives, for providing narratives. So one of the problems is that a lot of narrative planners have to be re-implemented every time you use them in a different context. And so some of this work is getting towards having sort of reusable modules in this space. And so a key idea of this work is encoding actors' goals and encoding the narrative system in a way that enables both local and modular reasoning. And this has several effects, but one of them is it can make queries easier for end users to express. So we have this general problem where if you want to know if something can happen, you need to have this really potentially have a sophisticated understanding of the system in order to express the query that you want explained. But if you can describe the way actors are going to interact with the system in terms of their goals, which may conflict with your goals, you can now start to describe the set of constraints that you're working in as modular on the modular, like sort of indexed on actors' intention. And so what this allows us to do then is to potentially lower the barrier for end users to express their, don't go to sleep, allows end users to express their queries in a way that potentially would be much more usable than having to express the full, propositional system. So some future work that is, currently in progress. I'd love to chat with people about. This is a lot of like what Shemaya's been working on. Have to do with things like updating the policies as we encode them so that they're also modular. So in addition to the fact that we need to understand how a system actually works, the code, how it's executing an environment, and how the law works, if you have a privacy policy that is both, needs to comport with the law or be consistent with the law, and describe the way that the code works, if you want to update it in light to changes of the code, we need to be able to do that in a way that doesn't require whole-scale rewriting of the system. We would also like to see these reusable, more reusable modules to express new laws or ensure future compliance. And so there's been some discussion here, and there's some very cool stuff going on that people have, posted about or have talked about today regarding some higher level systems where people could potentially reuse the concepts and relations that are being encoded in some of these ASP systems. And finally, there's some work that Chinmaya has been doing on allowing policy authors to be able to actually test scenarios against the system that they have. And so if you, for example, see reported some sort of privacy violation that's in the news, you could encode it in your system and use that in order to figure out whether or not that violation is possible in your system. And so in summary, this particular narrative generation approach allows us to actually have verifiable, modular, explorable, and interpretable privacy policies that end users could use and policy authors can update. So that is a high-level description.
Thank you very much, Emma. Do we have questions in the room? So if I've understood correctly, technical questions should be addressed in the chat because Chris is here to answer them, but you may have other non-technical questions. Yeah, go ahead. Chris, I didn't recognize you because first time I see you in a suit, but this is your for after. You're coming at 4. Yeah, you have a question here.
Would you have a ready example of a generator narrative available to share?
Oh, of the actual system?
Yes.
There's code online. There's not currently as far as I know, there's not currently like a live system, demo system. So we are working on making like all of these pieces together for someone to actually go in, and start typing stuff up. But there's a lot of different pieces that are currently in place. I can put up here, I can plug back in and give a link to, I need to double check that the link is that the repository is public, but actually Chris would probably be able to check that right now since I have the other windows open.
So thank you for a very nice talk. There seems to be a lot of relationships also to what we are doing, so I will explore that. These narratives, were they checked against the rules? So when you create them, you're sure that they actually follow the rules?
So the narrative generator and the policy system is layered on top of the narrative generator, as I understand it.
Okay.
So I'm going to also pull up the log into the AirMeet just to make sure that we're all. Is somebody monitoring the AirMeet right now? Okay. Yeah. So they should be consistent with each other. They're using a shared infrastructure. And so the policies that are written on top are using a bunch of, rule sets that are defined on the layer underneath.
Yeah.
Oh, no.
Okay, but yeah, I can also ask offline, but yeah.
So Chris, maybe you can. Are you allowed to talk? Yes, you should be allowed to talk right now. So if you, yes, please ask your question, and then we're going to.
Okay. Oh, I can even turn on video. I don't know. Oh, well, that's not the right video, but that's fine.
It's fine.
Can people hear me?
Chris, I can hear you.
Awesome. Yeah, some people are asking, and I think this was one of the questions in the room, and someone repeated in chat, like having an example narrative would be useful. And I wanted to kind of to point out a couple of the scenarios that we've been thinking about and sketch a couple of the case studies that we've been building and what kinds of narratives those pertain to. So part of the reason that all of this is feels very vague is that it's, when you say an example of a narrative, what we really have encoded to start out is an example of a scenario, which I think of as a sort of proto-narrative. It gives rise to a possibility space of narratives. The narrative planner is something that can generate many possible narratives, depending on what the specific user interaction is, that what kind of question they have to ask or what kind of information they want to specify as part of whatever they're trying to do. But so one of the scenarios that we've been thinking about, Emma mentioned social media sites like Meta. So a scenario might be, for example, you're a new user, you're considering joining a social media site. This is actually becoming even more like less and less of a contrived example as more and more people are joining federated services like Mastodon and trying to navigate like what instance do I join, because they want to join instances that have policies that are congruent with their values and with how they want to use the social media site. And basically, when you're making that kind of decision, instead of reading a complex policy and trying to extrapolate in your head all of the possible scenarios that might be relevant to you, the idea is you could go to like a tool based on the system that we're building and say, okay, my situation is, I'm a new user. Let's say I sign up for this and I make a post, and then and I have some people who have just followed me, and then I set my post to followers only. Can my new followers now see my previous posts, like from before they were following me, right? Like that would be a concrete example of a question that a user might ask, and that could have a narrative form answer, right? It's kind of a yes or no question. You could say like, yes, they can see those posts, or no, they cannot. But if you think of it, this is also kind of betraying my like background as a constructive logician in a sort of proof relevant sense. It can tell you not just, yes, someone can see your post, but also here's a specific story about someone who, like give a name to this person who has now followed you. Here's the specific sequence of steps that they can take in order to retrieve that information. So that's just to give you guys a flavor kind of the type of scenarios and questions and stories that we're thinking about. Okay. Let me know if that clarifies.
Thank you very much, Chris. It is now the time for a break. So if you have more questions for Emma and Chris and Chimaya, please ask them on the chat, and I'm sure they will answer them asynchronously. And I think we can thank them again for their presentation and their work. And move to the break. We'll be back at 4 with Chris. Chris Bailey's keynote.